Alright guys, my talk is today about event loop in JavaScript. Basically when I started doing JavaScript, I was like, I don't know what JavaScript does under the hood to make the code run in the browser nicely. So this is sort of an investigative process that I've gone through. I'm Suresh, I work as a front-end developer at CTR Digital. You can use my surname for a password, it's pretty strong. The first thing is, before I begin this talk is heavily influenced from JS Config talk by Philip Roberts. He talked about the event loop in a way that I, as a front-end developer, could understand. So I'm just going to share some things that I understood from the talk and a few of it. To begin with, I assume everyone is like a JavaScript developer here, so everyone knows what JavaScript is. It's just a scripting language for the web. It's not for the web anymore. You've got MJS and a bunch of other things. It's basically single-threaded, so you just can do one thing at once. But we'll get to that. It may be multi-threaded, but we'll see how it goes, basically. So as I said, this is a heavily influenced from the JS Config talk. So, and I started like investigating what JavaScript does. When they said it's a single-threaded, it runs one thing at a time. I was like, okay, that means like I got multiple jQuery functions. I got like normal like event loop or event that's calling in, like click and mouse events and like drag and stuff. Everything runs like smoothly for me as a front-end developer. And I see it, oh, it's just running everything at once. So it's not like a single-threaded thing anymore. But so I started like my Google search with this, like, if there is any kind of concurrency inside JavaScript. And basically, as I did, like, okay, I'm going to hit the web and see what the web is going to tell me about it. So, there were quite a lot of resources. I sort of thought of doing some kind of like mental map of like how JavaScript works based on my research. And then came up like loads of other results which like contradicted with the ones I had done. Then I went back changing that again. And then I got a bit more stuff that added in using web workers and like generators and year 6 and year 7 things. Then I went back and changed it again. None of that made any sense. So it felt like I was just riding in a death well. But basically it's like I'm just going around in circles and I'm just getting nowhere. That led me to the sort of like really frustrated moment that I don't understand what JavaScript is doing. That's when I watched the JS Config talk and then basically get an idea of what JavaScript does. Before I begin, I just want to say about like what JavaScript does. I need to understand what JavaScript engine does to the JavaScript. So as we all know, JavaScript engines are like the interpreters which just runs the JavaScript code. And basically it just executes the JavaScript inside of VM. Basically these engines are mostly used in these days in a web browser. There are also several other implementations of it as well. So for my researchers, as you all know, the JavaScript engines like Chrome's V8, I use Chakra engine, before it was I used Trident, I think Safari's Nitro, and Opera right now just V8 engine they have inherited. And just a quick quiz, does anyone know what engine Firefox runs on? Aye, very good. I got a little token for you. It is SpiderMonkey, but I'll give you that. But it's right now they changed it to EgoMonkey. So you get a whole hook and then
thank you very much.
So basically what EgoMonkey is just a love child of Safari Nitro and a SpiderMonkey. For my talk today, I'm just going to concentrate on Chrome's V8 because there's quite a lot of resources about V8. There's a really good talk from Google I/O about how V8 works and inner workings of V8. So let's see. When I started doing JavaScript, I thought it will be interpreted by the browser, then compile it, and then run within the browser. But it seems like it's not the case because what happens is like the V8 engine compiles the JavaScript in its own way, and adds a shitload of optimization, really cool optimization bits. And then it spawns out a code which is completely different from the JavaScript code we got. There's a sort of a tool which basically shows you how the V8 engine would run this code. So it's called Hybrid. I'll post a link as well into it. So this is how a normal loop just looks like in a V8 sort of code. So what I'm saying is like, so this means like there is no way of understanding, I mean, like, what JavaScript does inside it by looking just at JavaScript code I got. So when I did a bit more research around these engines, I sort of ended up with this theoretical model, which is just a schematics, but there are quite a lot of things that's going on in that which I have abstracted it, just for the purpose of my understanding. So you got, in every engine, you got a memory heap, the call stack. So the memory heap, it's just, as you know, it's just a memory. It's just a sort of unstructured area of the memory where it stores all the objects. And the call stack is it registers the function and calls the function one at a time. So it's not going to do multiple functions at a time. It just goes through the queue as like it's execute the first function, then the second, then the third, then the fourth. So that's basically is the call stack. And you can see in Chrome DevTools, you can see the memory thing. And also the call stack, the flame chart is pretty cool these days. So if you got any JavaScript code, you can see what are on the call stack. So this is a simple code just to explain the call stack, how the call stack is, basically. So assuming this is a call stack, this is a simple JavaScript, which just squares it with a multiply function with that. So as we go through, let's assume I got a main function, which sort of like scopes it out. So I got a main function there, and as it calls the square function, gets pushed into the call stack, and then it goes inside it, sees the multiply function, and that gets pushed into the call stack. And once the multiply function returns something, once the function returns something, or once the function has ended with closure, it's going to pop it out of the stack, basically. So once it's run through the whole function, it's going to pop it out, and then you get the 100, which is the square value of that. So this is a normal kind of call stack. But if you intend to do something like this, then you can see what happens to the call stack. It's like I call a function through, within a function through, then returning a function through. So it's a silly thing to do, but you ended up with like the stack being overflown. And then you get an error that's saying that Chrome saying, I can't execute so many functions at a time because my call stack is going beyond my limit. So since we understand that call stack is executing one thing at a time, and it can't really go for doing parallel kind of processing. So the magic happens when something like this, like a set timeout here, has been put in. Remember, I got set timeout 0 as well. So a set timeout comes in, and then it disappears. And then when my code comes in here for the square, it gets pushed into the call stack. And then it goes to multiply inside the square. And then it gets that, and then the multiply disappears after returning, and the square returning, it disappears. And after everything disappears, I got the log result, and then the console.log, basically. So at the point of execution, where you got this square and multiply, this function has disappeared from my call stack. It's never to be found in my call stack. So this is where all the pieces of like the event loop fall together. So the first piece of the event loop to get to the event loop is the web APIs. This is quite a bit of a surprise for me, because I always thought V8 had its own sort of like set timer, RAF, and like geolocations, and HTML5, audio video APIs, and JavaScript DOMs, XML HTTP requests. It's all inside V8. But I was shocked to learn these are all not inside V8. The V8 is just a stack and a heap. So the web APIs, or the browser APIs, are the ones which provides all these APIs to the V8. So if any of this API calls are made, it just goes to the web APIs, and then it's going to say to the web API, you do this thing. It's going to say to the browser, you do this thing. So our set timer goes here, and then it waits. But the web API can't push everything into the call stack immediately, because there might be some stuff running already in the call stack. So you don't want to break the call stack by inserting something in that. So it pushes into a task queue or a message queue. So this task queue is first in, first out. So you got last in, first out. So you got everything pushed into the queue. And basically from this queue, we got our wonderful event loop. So this event loop guy, what's he going to do is like, he's going to check the call stack. When the call stack is free and available, that's when he's going to take the first item off here and then push it into the call stack. So that means, even if I had a set timeout 0, it's obviously going through the web API and going here, and then the event loop checks here, but it's still running the other functions, so it's waits for all the call stack to be cleared, and then pushes the set timeout here. So what's this basically, from the Flip Robot stop, he has done a tool just to visualize it, how sort of this event loop thing works. Which is a pretty cool demo. I'll just quickly run through it. I don't know if I have time, but I'll quickly do it. So, you got a web API, which was just a click button, and then you got a set time like that. So, if I'm going to click this button, so I'm clicking it, and the set time up registers here, the click action is already being performed, but then it goes to the callback queue, and then pushed back again into the call stack. So, this kind of a deferred aspect of it gives it unique advantages. So where it's getting used, what's the purpose of this? This means you can like execute a code in the web API, at the same time the call stack is doing something else. So these are potentially used these days in async callback or promises. If the promises have like set timeout 0, this is what it's ideally doing, it's just staggering the code. Excel request, or like you got a processing intense kind of canvas performance, or like you're doing some kind of image manipulation, then stuff like that you can really try and work that. So when I was doing that, then the web workers hit me. So this web workers, I want to see how the web workers work and like how it affects the event loop and where it's coming into the piece of the event loop. So web workers, they have their own execution model. They have their own little sandbox, like like the iframe. So it offloads all the expensive processes, and it's got its own call stack, event loop, and heap, and a whole lot of it. But how it communicates with the other thing is using message passing. So our call stack sends a message using message passing to a web worker to trigger the web worker. Web worker finishes everything, and then basically it's processed the message back again. So that message gets processed, and then it's put into the message queue, and then you go back into the call stack. So this kind of like worker interface would give us something like a multi-threaded processing system, where you can process 2 things at a time, or even 3 things at a time. And why should we care about all of this? Because performance matters. If you have seen the recent sort of like performance thing this year, it's more like Google's pushing on something like a layer kind of attribute, where it's like you just get a performance budget for each bit of your web application states. So you got a load state where it makes the HTTP request and then gets all the data and everything. You got your critical rendering path and everything in the load state. And then you got an idle state. Idle state is before the user actually interacts with your app or your website. So this idle state is like about 100 milliseconds as per Google. So this 100 milliseconds is very important for a JavaScript developer to do all his processing in that 100 milliseconds. Because nothing is happening on the page, users not interacting with it. So once we get that kind of 100 millisecond is very, very short. So if we understand the event loop and the web workers and how it fit into the puzzle, then we have a chance of breaking that 60 frames per second barrier. Saying that like once this is a table by Polish, which basically he says you got around like 60 milliseconds when you are loading a page to run or to process all your JavaScript. Then when you are doing any animations or any responses, you got even less. So that means heavy processing has to be done before your page is like your user interacts with the page. If you want to know more about like critical rendering and everything, there is a Udacity free course which you can see in this link. And what's the future is like for this promises and callbacks? Basically, we got in ES6 or ES 2015 we got generators, which is basically the same thing it's going to do, but in a nicer way, and it's all built in. You see the function, we got a star there, this is a generator function. When you call this function, it's going to return an object, generator object, and it's going to run through until it sees the yield statement. So when it sees the yield statement, that's where it's going to stop. So once you say next, that's when it's going to continue again. So this is just a Fibonacci function, which just returns the sequence of Fibonacci numbers. So when you say next, it's going to go the other way, and then the yield also returns the value of A, so which can be accessible through this value. So that is just how it runs basically, and for ES7 it's the same. You got more kind of a semantic syntax where you got async and await, which basically does the same thing as well. So these all fit into the event loop nicely. There is one other thing they are discussing about it currently. It's like communicating the event loop concurrency. So you've got a concurrent event loop as well. There is a possibility they are discussing about implementing a concurrent event loop model in ES7 and ES8. If you want to know more about it, and if you want to join the discussions, you can see this link and then get involved with it. And that's about it. Thank you.
No questions? No?
Cool.
Okay, let's switch over.
Thank you.